Good morning. Today we are on page 51 of your student journal, and our objective for the day is, today I will compare fractions using common numerators. Period. So let me scoot that up for you. A couple days, or our last video actually, we did something very similar. I'm going to flip back and show you. We compared fractions, but last time we did this, we used common denominators. So we're going to be doing something very similar today, but now we're going to be using common numerators, which remember is the top number of our fraction. So just a quick reminder that the multiplication property of 1 says the product of any number multiplied by 1 is that number. This property is also known as the multiplicative identity property because it doesn't change its identity and it doesn't change its value. So we had talked about all the fractions that are equal to 1. A fraction is equal to 1 when the numerator and the denominator are the same. So 2 over 2, 5 over 5, 9 over 9, 6 over 6. And we could go on and on. As long as the numerator and the denominator are equal, then that means that this fraction is equivalent to 1. So when I multiply a number by this fraction, I don't change its value. Okay, our steps today are going to be very similar to how they were in the last video. We're just going to change one thing. So we're still going to write the fraction being compared, and we're still going to be multiplying by 1, but this time we're going to use the numerators of the second fraction. And then we're going to write the second fraction being compared and multiply by 1 using the numerator. Then we'll be replacing the original fractions being compared with fractions with common numerators and compare. Okay, so you're probably going to see a lot of similarities today to what you did yesterday. Okay, so here's my first problem, and it says 2/5 compared to 1/2. Okay, now it's really hard to compare those unless I was to draw models or to draw number lines. So another way we can compare them is by making them have common numerators. So what I'm going to do is I'm going to say 2/5, and I'm going to look at the opposite numerator, which is 1. So I'm just going to multiply by 1 over 1, which will not change it at all. So 2/5 is going to stay the same. Then I'm going to change 1/12, and I'm going to multiply it by a fraction equivalent to 1 using the opposite numerator, which is 2. So now I get 2/24, because 1 times 2 is 2 and 12 times 2 is 24. So 2/24. Okay, so now they have common numerators. So the reason I can now compare these is, let's think about what a fraction means. A fraction means the denominator says how many slices the whole was cut into. So imagine this was a cake, okay? So this cake was cut into 5 slices. 1, 2, 3, 4, 5. That's what this denominator tells me. This denominator of 24 tells me that their cake was cut into 24 slices. That's what the denominator says. How many was the whole cut into? Now, in both fractions, you have a numerator of 2. So in both fractions, you get 2 slices. So it's pretty clear, even if I didn't draw the model, which one would be larger. This one's larger because the whole was cut into less slices. That means the slices are larger. So 2/5 is larger than 2/24. And it's because this denominator means that the whole was cut into less pieces, which means the pieces will be larger. Okay, so let's look at another one. 2/8 compared to 1/3. So if I have 2/8, I'm going to multiply it by a fraction equal to 1 using the opposite numerator, which gives me 2/8. That didn't change. And then 1/3, I'm going to multiply it by a fraction equal to 1 using the opposite's numerator, and I get 2/6. Okay, so in both of these you're going to get you have 2 slices. Which one has larger slices? Picture this a cake. This cake was cut into 8 pieces and this cake was cut into 6 pieces. So wouldn't these slices be larger? So 2/6 is larger than 2/8 because the whole was cut into less slices or partitioned into less slices, which means the slices or the fractional parts are larger. Okay, let's try some together. So we are on page 52, and here is our first problem together, 9/12 compared to 3/4. Okay, so we're gonna look at 9/12, and we're gonna multiply it by a fraction equal to 1 using the opposite numerator. So 3/3. So we get 9 times 3 is 27, 12 times 3 is 36. Okay, so 9/12 is equal or equivalent to 27/36. Now let's make an equivalent fraction for 3/4. So we're going to multiply it by 9/9. And we get 3 times 9 is 27. 4 times 9 is 36. Okay, so let's look at this one. This means that in both fractions you have 27 pieces or parts, and both of the wholes were partitioned or cut into 36 parts, which means the parts are the same size and you have the same number of parts, which means those are equivalent fractions. Okay, let's look at our next one. So we have 3/6, and we're going to multiply it by 2/2. So we get 3 times 2 is 6, and 6 times 2 is 12. So 3/6 is equal or equivalent to 6/12. And 2/10, we're going to multiply it by 3/3. So 2 times 3 is 6, and 10 times 3 is 30. Okay, so let's think about this. Both fractions I have 6 parts, but this whole was cut into 12 parts and this whole was cut into 30 parts. So which parts are larger? Wouldn't these fractional parts be larger? So 6/12 is worth more than 6/30. Okay, so ladies and gentlemen, as you're doing these next 3 pages on your own, think about that. Really picture like a cake being cut up to help you determine which one has larger slices. Have a wonderful afternoon. Bye-bye.